Okay. I was about to get started. Maybe he's in the wrong place. There are about 7 or 8 of you missing, so I sent Benjamin over to the low building to see if they're waiting over there. But since I've worked with him before, so he already knows the beginning of what we're going to cover. So this is 6010, Industrial Systems Engineering 6010. It's applied regression analysis. And I'm Stanley Dunn, and my office is in the Office of Graduate Education. And if you need to reach me, you have my email address, so you can always just send an email directly. And if you need to see me for some reason, or you want to make an appointment to see me, if there's something in class you're not sure about or anything in general, please contact my assistant at the phone number there. So it's extension 8433. And you'll be able to get an appointment. Okay, so there's the rest of the group. I'll wait till you get a seat. Okay, we're just getting started for the rest of you that walked, that walked in. I'm Stan Dunn, and I happen to currently have the pleasure of serving as the graduate dean, so my schedule can be a little erratic from time to time. It may be the case that I get called out on the last minute, so I get to leave my phone on, and I'm going to ask the rest of you to keep them off. If for some reason I get called to the administration building, I'm going to have to stop and go, but we'll find a way of making up the time, and so I apologize in advance if I get called out of here. It hasn't happened too often. Over the years, it's happened once that I can think of. And since we're only meeting once a week, it minimizes the amount of time that it happens. So just be careful. So there are 2 ways of teaching regression, and I'm doing it one way. We could start with the book and spend a lot of time talking about theory and talking about algebra. And I'm not really interested in doing that. What I'm really interested in doing is starting from a first principles approach. So we're going to start by talking about very simple mathematical models, and we're going to work our way up, by the end of the semester, into time series models, and we'll talk about categorical predictors as well, and some other topics. But I tend to think of this as a first principles approach. I'm not so interested, you're going to have to do some algebra, although I'm not so interested in the algebra. What I'm really interested in is if you understand the material. We'll talk about several things. We'll spend a couple of weeks talking about assumptions once we get through some of the basic material. And we'll cover toward the end of the semester nonlinear regression, and 2 topics that will become clearer as we move on, and that's interactions and moderators. You're going to have an application every week. There is no homework here. There is no exams. We will have a discussion board assignment every week that you're going to be expected to participate in, and we'll have 4 projects in the class. So there's no homework, and you're not going to have an exam. I'm going to spend a lot of time talking about real-world applications, and I'll be looking for you to interact here as well as interact online. We'll be meeting here once a week, and we'll be meeting in this room on Thursdays, and I'm glad to see that everybody seems to have found the room. We'll be meeting here on Thursdays from 10 to 11:20, or roughly 11:20, maybe 11:30 if I have to stretch it a little bit. but we will not be meeting on Mondays. And we won't be meeting in the low building. We will be meeting here. A lot of the course is going to be transferred to online material. So a lot of my lectures is going to be replaced by discussion board activities where you will be required to work on a problem every week, to post your solution, and then you're going to be required to interact with the rest of the class. That's going to be a replacement for what we did. So those of you, excuse me, those of you that were with me in the fall know how this works, and for the rest of you, this should become clearer over time. I'm going to try to start each class with giving you the opportunity to ask questions. You may notice that I'm walking around with a microphone. There's another group of students who are actually taking this class. They're not here with us today, and they're not here synchronously, but it's another group of students that are off-site that I'll be visiting periodically. It will not affect our meetings here on Thursdays at all. So I want to be able to take advantage of our interaction here for the benefit of the students who are not here with us. So I want to give you the opportunity to ask questions. Of course, I want to encourage you to interrupt, when necessary. If I'm moving too fast, I'm going to, ask you to make sure that I slow down and go at the right pace. So let's start. Any questions for me right now? Yes?
How do you sign in the discussion board?
How do you sign in the discussion board? We're not using the Blackboard learning management system. We're using a different learning management system called Canvas. Did you register for the class?
No, I haven't.
You haven't registered yet. So at the end of our session today, I want you to see one of my colleagues over there, and you'll get registered for Canvas. I'll show you what it looks like, and I'll show you how to get into the discussion board. So you'll get to see. Other questions? Yes?
Is there any office hours?
Is there any office hours? So office hours are by appointment. If you need to see me, please contact. I think you came in a little bit late. If you need to see me, please call my assistant at extension 8433, and we can make an appointment. If you do need to reach me directly, if you have a simple question that you want to be able to ask, my email address is there. What I'd really like to do, though, is to have most of our interaction online for the benefit of this co-group, but also for the benefit of the other 13 students that are taking this off-site. So there is a discussion board called Office Hours. And if you have a question, I'd like you to go there first. We can meet if absolutely necessary. Okay? Other questions? All right, so some house rules, some rules that will govern what we do. If I'm talking too fast, I am going to ask that you slow me down to make sure that you understand the material. If you don't understand what we happen to be doing, please ask at any time. Do take advantage of the online discussion boards, either for the assignments or for the office hours, which you'll find. And what I may, depending on the amount of activity, what I may do is post a separate discussion board for each topic, so you can ask questions for the benefit, thank you, for the benefit of everyone else. I'm not always right. If you happen to think we're going to need some more seats here, folks. If you happen to think that I'm wrong, then I want you to ask. Don't be afraid to ask a question. I'd just as much be happy to have a discussion here rather than me lecturing the whole time. Okay. I'm assuming you're here because you want to learn a new technique, or we want to, we're going to learn together new techniques about regression of many sorts. The best way to learn this is to work on real problems with real data. So every week you'll have a different assignment. It's not homework per se, it's a discussion. I'll show you what this week's question is about. The second best way is to use your own data. So you'll have 4 projects in a semester, and each one you're going to use a data set from a set or a list of data sets that I have available that will show you. And that's really my data. We're going to switch. Normally, I teach this using the R programming language. We're not going to be using R this semester. We're going to be using Minitab instead. There are a couple of reasons why we're going to be doing that, and it's mainly to focus on the material rather than focusing on a lot of or adding it with a lot of our programming. So those of you that have Macs, and I see a number of Macs around the room, you have a bit of a problem because the full Minitab installation is only on Windows. Now, there is a small there is an implementation of Minitab for the Macs, but it's not complete. It should be enough for us to do our work in this semester, but it's not a complete implementation. So I encourage you to go to the Minitab website, download it, give it a try to do the discussion board activity, and otherwise, if you're unable to do it for some reason, then we'll need to talk. You'll need to find a Windows machine that you can use. You'll have to use Excel from time to time to get your data into order, right? You're going to be working with large data sets, that you'll have to truncate. Some of the large data sets have additional columns in there that you're going to want to remove. And you'll use Excel primarily to prepare your data for Minitab. At some point during the semester, you're going to use another program called G-Star Power, because something that we're going to talk about is power analysis. If you're not familiar with power analysis, what I mean is making sure that you have enough data to actually make the statistical inference that we're going to be talking about. It is a free program. There is a Mac version. There is a Windows version. So we shouldn't have any problem using G-Star Power. What I mean by NHST is null hypothesis statistical testing. I'm assuming that everyone here has had at least a basic course in statistics. Yes? No? Has anybody not had a statistics course? Everybody has had some statistics. You have not had any statistics. Just a little. Okay. Well, that's all right. We're going to start from the beginning, so you should be okay. All right. So there's 2 things about the order. What I want to do is get through some slides today. Number 1. Number 2, I'd like to show you Canvas for those of you that are not familiar with Canvas. And number 3, we'll look at Minitab and show you some of the initial discussion board exercise that you'll be, that you'll be using. All right. Any questions before I begin? The slides that you have will be posted online before our lecture. So this week, since we're starting today, the slides for today are posted, but you'll also have next week's slides. Periodically, throughout the slides as you go through it, you won't have the voice over PowerPoint. You're just going to have the slides to look at first. You'll encounter, as you look through it, black boxes. So I've blacked out some of the material on the slide. And the purpose is I want you to try to see if you can't figure out what's missing. Okay? And if you can't figure out what's missing, that's okay. I don't expect you to always be able to do it. But what I want you to do is to come back to class with the question. Right? And that what we should be focusing on here, I'll go through the material, but we should be going through here are the material that's missing, because that will help you, learn the subject material. So I'm doing it a little bit backwards. This is not going to be just a class where I'm going to stand up here and lecture and give you the material and give you homework and tests. It's far from that. You're going to have to be actively involved. You have to look at the slides beforehand, because if there are no questions that'll come up, then I'm done for the day. Okay? And the discussion board activities should help, help you learn the material or help you reinforce the material that we're going to cover in class. Okay, so let's start at the beginning. I promised you that we'd start from first principles. We're going to start at the beginning of regression, and I'm going to talk about models in statistics. So, what is statistics all about? Why do we have to learn statistics?
Find relationships.
To find relationships between data. Okay, so it's about models, right? I mean, a model is a mathematical description of the relationship between multiple sets of data. I won't say just two. We'll start out with two, but multiple sets of data. That's very good. We'll need another chair. What else?
Finding some rules.
Some rules. And by rules, I'd say that's still models, right? A rule is a relationship, right? Isn't it? Okay, a rule is relationship.
Causal relationship.
To what relationship?
Causal relationship.
I'm sorry.
Hypothesis.
A hypothesis, an idea about a relationship. Okay, so good. So there are many things, but also I want you to keep in mind that the answers we've talked about: models, relationships, ideas about relationships. All kind of assume that the data is perfect, right? And we don't have perfect data. There's variation in data. So, what I tend to think is that statistics is about the management of variation, right? And in this class, it's about models. So it's about developing models in the presence of variation, right? You're going to have, we're not going to have perfect data by any stretch of the imagination. And the challenge for us, right now and by the end of the semester, is to find ways to determine these relationships, to determine these models by minimizing the impact of the variation. Okay? So right now we're going to talk about models and statistics. We're going to talk about error. And the simplest model that you're going to talk about is the mean, or the average, the sample average. And we'll talk a little bit about what is called ordinary least squares estimators, of the model. So we talked about what's a model. It's a relationship between data. There are some independent data. There's data that's dependent upon, upon this as well. And we want to determine the relationship. So, I said statistics is about the management of variation. It's a representation, right? It's not reality, because there is variation we have to deal with. It's a representation of reality. It's not reality. If you have a model airplane, it represents an airplane. If the model was exactly the real airplane, then it isn't a model. So model is a representation, right? It's a relationship, right? It's a rule. Okay, so statistics is about developing these models, and we all know that because we already, have the answer. We're going to introduce a term called parsimony, and parsimony is about the simplicity of the model. I mean, the one thing that we want to do is develop models, but we don't necessarily want the most complicated model. We want to start with the simplest model. Right, and it's often one thing I want you to keep in mind as we move on through the semester is the simplest model always works the best. Okay, so we want parsimonious models is really what we're after. So the parsimonious model should be able to explain a lot. It uses as few concepts as possible. It's the simplest thing. The fewer concepts. Such as if you lower the price, is it worth paying a higher price for a better model? Right? Is it worth paying a higher price for a better model? So what I mean by price in this case is a complicated model. Is it worth paying the higher price for a better model? What do you think? Benjamin, what do you think?
What you're going to use it for. So if it has to do with like a human being's health, for example, then you might want to spend more, but something that's less important, then you can go to the cheap.
So, okay, good. So the model depends upon the application. And if it's an application that's important as healthcare, then you probably want a more complicated model. We'll talk toward the end of the semester about stocks and bonds and trading, and we'll talk specifically, you'll have an exercise about Google stock. Okay. I would think that financial services industry is probably also a case where you want an important model. What about a simple laboratory experiment? Yes?
It depends on what you want to get from this model. If you want a specific result, well, it is worth. If you just want a trend, it's no worth.
Oh, okay, good. If you want a specific result, you'd probably want a more complicated model to predict, right? To predict what's going to happen. If you just are interested in determining the trend, you don't need a complicated model. So an example of a non-complicated model might be something like the mean, or a very simple regression problem. Right, that's very good. So our first model that we'll talk about is the mean at the model. And you all know the mean. It's the sample average. You've learned about it in previous statistics courses, whether you've had it at the undergraduate or the graduate level. You've learned about it at school. And a mean happens to have a special property called ordinary least squares estimator. Something that I'll talk about are blue as estimators. And I don't mean blue because it's the color blue. I mean blue because it's called the best, B, linear, L, unbiased, U, E estimator. It's an important concept in regression, the best linear unbiased estimator. And it's related to ordinary least squares. So a mean is the simplest model, right? It's parsimonious. Can you use it to predict, can you use it to predict healthcare issues or stock prices? Not really. It's best in some sense. It'll help you explain a trend, but it won't help you in a prediction sense. All right. But first we want to talk about unbiased estimators and ordinary least squares, so let's back up. Remember that a model is a representation of data, and that the true data is the model plus an error. Or that the error, you think about the error, is the data minus the model. I tend to try to walk back and forth, and I'm sorry for those of you on the other side if I happen to be standing in the way, and some of you over here. I'll be standing in a way periodically, so I'll tend to walk, back and forth. right? So the difference, you have true data that you've collected either from an experiment or from some other survey data set, or if it's financial services, you've collected stock prices and you're looking at trends. But you have real data and you have a representation of that data that happens to be a model. And so the difference between the two is the error. Now, what do you want to do with the error? Do you want to maximize the error? Do you want to minimize the error? Do you want to get rid of the error? It's always going to exist because, remember, statistics is about variation, right? What do we want to do with the error? What do you think? Just, give me some idea. I don't expect you to know the answers right away, but I do expect that you're going to rely on your intuition. And I really want this time that we have together, because it's only once a week, to be conversational.
Minimize error in order to enhance predictability.
Okay, so if I minimize the error, then that should improve the model. Right? Good. All right, so you want to minimize the error. And I talked about ordinary least squares on the previous slide, right? It was here. And the purpose of the ordinary least squares procedure is exactly to minimize that error. So it'll produce the best model by minimizing the amount of error that we have. Okay, so here's a set of data. And there's the model. And what's the first error? 0.2 or minus 0.2? Minus point, who said minus 0.2? Okay, right, because remember, it's data minus the model. Right, so that's minus 0.2. Okay, and the rest of them you can see here. All right, so what's the purpose of the ordinary least squares procedure to develop a blue estimator, right? Is we want to change this. Right, I'm going to want to change this, right, to minimize the sum of these. Okay? And that's ordinary least squares. Right? So I'll be changing this, and every time I change the model, we'll go through the exercise we just did, and then the errors change. And I want to continue to do that process until I minimize that error. Right? Ordinary least squares. And what I get out of that is this model that is the blue estimator. How do I turn off the pen?
Hit the pen again. Is that your time? Yep. And then just hit pen again.
Got it. Thank you. Okay, so here's your first black box, right? And when you look at the slides every week, you'll see a set of black boxes. And if you look at next week's slides, which I'd encourage you to do, right, is look at the black box, and a purpose of the black box is to get you to try to fill in the material that's missing. So let's get the pen back. I'm going to do it in white because the background is black. And so what's missing from this slide? What's the next equation, right? This is the error. And if you remember the last slide, I had the sum of error, right? Y sub I, when we use the term Y sub I mean the real data. And Y with a hat, or the caret above it, is the model. Okay? Now, we're talking about the average, right? This is our first model, the average of the data. So our first model is B0. B means a coefficient of the regression equation. 0 means the average. And so this is real data minus the average. So here's some algebra. Wait, what's next? What do you think is next? This is the kind of exercise I'm going to ask you to go through. Right? The sum is linear. What do you think? What do you think is next here? Right? Well, the sum is linear. Yes.
The sum over number of the variables.
The sum over
The number of variables.
over the number of values. So we'll call that n, and I'll put that underneath. And what's in the summation? Well, I can separate out the sum, right? So this could be the sum of y sub I minus the sum over n of b0. Correct? Right? Everybody follow so far? All right. Do I know what the first term represents? Right? It's the sum of all the data. Right? So there's nothing more for me to do with this. It's just simply the sum over n of y sub I. What can I do to the second? B0 is a constant, isn't it? So B0 comes out of the summation. And then what's the sum over n of 1? Just, what did I do? Okay. So this is n times B0. So what does that mean? Right? So that I can use this to determine B0, can't I? B0 is the sum of y sub I over the data n. Right? Simple algebra. This is exactly the kind of thing. When you see a black box in the slides, this is what we want you to try to figure out. Okay? So what this last equation tells me is that if I'm trying to minimize the error and I'm trying to develop a model that's just the average, you can see that this is just a sample average. All the data divided by the number of data gives me the coefficient B0. Great, questions? That's our first. First model. Yes?
You will have to assume the equation equals to 0, so you will have this formula.
Yes. Yes.
So we can assume it.
Well, let's work it out. Change slides, change color, right? Equals 0, equals 0, equals 0 so far, right? Everything I've done is on the right-hand side, right? And then if this equals to 0, right, then I can move this term onto the other side, and I get this equation. Okay? So minimizing the error, making the error 0, gives me a model that's just a sample average. It's very good. Very good. Okay? Okay. Are small and large errors equivalent? If I have one error of 4 or 4 errors of 1, is that the same thing? What do you think? So look at the examples that I have given you on the slide. Here's an example where I have 2 data that are 2 and 1 data that are 5. If the model is a 2, then the error in 2 cases is 0, in the other case it's 3. right? So it doesn't represent it very well. If I have, in the other case, right here, data that are 2 samples of 2 and 2 samples of 4, and the value could be anywhere within that range. It's indeterminate, right? I don't know what the best model is, right? But one thing I can say is that there are an infinite number of solutions. But I don't want to find I don't care about any specific. Well, I do care about one specific solution, and that's the one that minimizes the error, right? If I had 2, 2, 4, and 4, the model could be 2, the model could be 4, the model could be 3, the model could be 2.5, it could be anything in between. Right? So here's another black box. And what is the sum squared error? Can anybody help me? Well, parse the sentence, right? Parse the sentence. What's the first thing in the sentence? It says sum, right? So it's a summation, and I have n data, okay? And what's the next thing you see in the sentence? I see squared and I see errors. So I have some term like this that's squared. What's the error? The last term in the sentence says error. What's the error? Y sub I, which was what? This is the data, remember. And what was the equation before? Error is equal to data minus model, right? And the model we denoted by y hat. Okay? So this is true, right, for any model here. And I would like, to make this equal to 0, right? So how can I work this out? And what am I trying to find? Just the thought before we move on. Or what do I know, or what am I trying to find? I know 0, right? I know y sub I, that's the data we've collected. What I don't know is the model, right? Y sub hat, right? But I can, right? I can expand the summation, right? And then what can I do? Well, you can do it again, right? We know, right? We know what this term is. I can take out, in the second term, I can take out the constant y sub hat, and I've got the sum of y sub I, right? And then I've left here, y hat squared, right? And then I'm going to solve the equation for y sub hat, y hat. Right? So by minimizing the sum squared error, which, right, this is exactly what we just did. By minimizing that error, I find the mean. All right, what we just did was ordinary least squares. Ordinary least squares. I minimize the error, and the error is the difference between the data and the model. Right? If you minimize this, you get the mean. Right? So depending on whatever value I have for B0, you'll get a curve like this, and eventually you'll find the mean using the data that we had before. at 1.6, right there. Okay? Questions? Everybody with me so far? All right. Now, for those of you that came in a little bit late, I said I'm not really interested in a whole lot of algebra, but I just did the algebra, and I did it because I wanted to just, show you some of the background. I have on a slide, that you can prove that the mean is a best linear unbiased estimator. And you can prove it with something called the Gauss-Markov theorem. And I'll tell you right now, I don't care about the Gauss-Markov theorem. You don't have to know what it is. You don't have to remember. You don't have to memorize it. You don't have to go look it up in a book. What I care about is if you know that error is equal to data minus model, and that you know how to solve it just the way that we did. Right? So ordinary least squares estimator, which is what we just did, are best linear unbiased estimators. Okay? And they're best in a sense that they have minimum variance, as we showed, and you can work it out that you get the standard deviation or the variance from the equation as well. Right? And it's closely related to standard deviation. So here's the data once again, right? The same data. And I get the model by minimizing the sum of the error. Whoops. Okay, so here's another black box. The first line says the mean has 5 degrees of freedom, right? And it's because I had 5 data, right? And the mean is called the first moment about the mean. We just went through a couple of slides really quickly about standard deviation, and I've done that because I assume that you know what standard deviation is. And the standard deviation has some number of degrees of freedom. How many degrees of freedom? 4. Can anybody explain to me why? Everybody knows the answer, right? It's 4 degrees of freedom. You know that it's 4 because it's n minus 1. But what I'd like to know is why. Well, sorry, please.
Yes, because you have already know the meaning of the 5 data, so therefore you only need to know 4 data of the 5 data, then we have the 5th data.
If I know, well, there are, right, there are actually, well, you're right. If I know there are 5 data, if I know 4, right, then the last one is already determined. You can do it with a very simple example. If I know these 5, then I know the sum, S, right? So if I'm trying to, determine the standard deviation, right? I'm going to, I need to compute this sum, right? Well, if I know these 4 or 5, then I know the sum S, and if I know the sum S, what does that give me? Right? That gives me the sample average. Right? So the sample average has 5 degrees of freedom. Right? Well, once I know the sample average, and I know 4 of these, first 4, can I determine the 5th? Yes, I can determine the fifth, right? If I know this from the sample average, this is just x bar over n, and I determine these four, I know the fifth, and that's what you explained to us. So the answer here is that there are 4 degrees of freedom. How many for the third moment, right? So the mean is the first moment about the mean. Some of this is background, right? I want to make sure that we all understand the background. The mean is the first moment about the mean. Standard deviation, second moment about the mean, which has n minus 1. Skewness is the third moment about the mean. How many degrees of freedom do you think there are? 3. It's n minus 2, right? N minus 2. And kurtosis is the fourth moment, so that's n minus 3. All right, so we know about degrees of freedom. And I'd like to move on and talk about Canvas for a minute. And let's see if I can get there. Okay. Can everybody should have received, if you've registered for the course, you should have received an invitation to join Canvas. I know many of you, have logged in. Some of you still have not. If you haven't registered and you're here to add the class, please see me after we're done, and so that I can get you signed up. When you log into Canvas, it doesn't look like Blackboard. If you've been using Blackboard before, this is what Canvas will look like, or at least this is what my view of Canvas will look like. There is a welcome message that I left. One of the first things you should try is to read is to watch the welcome message, right? It's some of the slides you saw today with a voiceover. Has anybody tried that? Anybody tried it yet? All right. This is just a test to make sure that you can use Canvas. So, watch the video. We're not going to use Adobe Connect, at least for right now. There is one module that's called Derek Young's regression text, and that's the text we'll use. You do not have to buy a book for this class. We will be using as background material this book by a colleague named Derek Young. Later on for your projects, you will be using sources of data from a link that's called 100 Interesting Data Sets for Statistics. Some of you may be familiar with this already. This link will take you, it's a link, as you can see, it'll take you to a website, and you'll get to choose from a number of different data sets that you'll be using for your projects. If you're not familiar with Minitab, here are 3 sets of tutorials that explain it pretty well. Has anybody used Minitab? You've used it? Anybody else? You've used it? You two have used it? Okay. How about the rest of you? All right, watch the videos. It's very straightforward. It's very easy to use, and if we have some time, we'll get through it. And we are in week 1, right? So this week, today starts week 1, and next week, right, starts week 2, and that's the 26th of January. And here's all the things that I'd like you to get through just to make sure that you're calibrated, right? They're relatively easy exercises. Right? Go to the discussion board and introduce yourself. If you click on the link, it'll take you to a discussion board. You can see it starts with, I introduced myself. And, then some of the other students have already introduced themselves, right, and replied. Right, so this is a test to make sure that you can use the discussion board activity. Simply click on the link, it'll take you here. Here are the instructions. and then you hit the reply button, and then you'll add your own introduction, right? So you should do that over the next couple of days. When you have a discussion board activity for each week, I'm going to ask you to post your own response first, and you have to do it by Sunday. The week will begin on Thursday. By Sunday, you have to have your answer. And then between Sunday and the next Wednesday, you have to comment on 3 other submissions from your classmates. Okay, so I want you to read what everybody else is doing and engage in a real discussion. But you have to do yours. You have to do yours first. Okay, so let's keep going with what we're doing. Introduce yourself. The next thing is install Minitab on a Windows machine. If you do have a Mac, as many of you do, you can use the simple version. Check to make sure that it does regression. I don't know whether it does or it doesn't. I haven't tried it, but we have the Minitab, we have the Windows version here. There are some activities that I'd like you to do with, make sure that you can use Minitab. 3 things that you'll have to do, especially for your projects, is learn how to display data graphically, numerically, and using a box plot. Right? The files that are MTW are Minitab files that you'll load once you use Minitab. The PDF files that go with these are a set of instructions that you should follow in order to use the activities. Questions about this? Okay. Next, read chapters 1 and 2 from Derek Young's book. Right, if you go to Derek Young's book, right, to get into the module, click on the little arrow, and it opens up the module as I just did. Right, and you'll see there are 4 parts. There's simple linear regression, multiple linear regression, advanced regression models, and appendices, and we will be using all 4 of these over the course of the semester. But I want you to read chapters 1 and 2 from part 1. Okay? That'll talk about simple linear regression. It kind of talks about what we did today with ordinary least squares estimators, with best linear unbiased estimators. And if we have a few minutes remaining afterwards, we're going to move on and talk about more complicated models. If you need help installing Minitab, here's an email message that'll show you where to get the executable file, the installable file. And you probably want to do that beforehand. Here are the 2 sets of slides. We went through slide set number 1 already, right? So you'll see the blacked out boxes. You'll see lecture 2 will have the same. And the next part that you'll see is the discussion board activity for this week. Practical.txt is your data set that you will use, and the instructions and the discussion board is called Contradictions of Statistical Significance. All right, here are the instructions. Folks, it looks worse than it really is. Okay, so don't worry too much about it. All right, so you're going to use the data practical.txt, and there are 1,000 entries in the data set. And I'm not asking you to do much more than to perform a basic regression analysis. So go through the Minitab tutorials if you don't know how to use it already, and simply perform a regression analysis, which we can do here. But I want you to do it on your own. Right? Then there are a few other things that you'll have to do. you'll get out a value called r squared. Remember, r is the correlation coefficient. R squared is the amount of variance that's explained by the model. Okay? And then I'm going to ask you to determine if the coefficient of the model is really different from 0. And then, you know, by using Minitab, you want to compute a confidence interval about the mean. Everybody knows what a confidence interval is? If you had a basic statistics course, you should have seen this. Does anybody not know? Everybody said, you're not familiar? Why don't you see me after class, okay? All right? Now, what you'll find out is that there's a difference. But, you know, there's a difference between the two. Right? So there's a contradiction. And you have to answer the question, what do you think is causing the contradiction? I'm not telling you what the answer is. There's a number of different answers that's correct. The purpose of the discussion board is for you to try to answer it, to tell me what you think, and then discuss it amongst yourself. You are not graded on the correctness of the answer. You're graded on the discussion, you know, that you'll have between each other, okay? And there's a second question that you have to answer. What would you suggest you do whenever possible when analyzing data? So this is about a basic exercise in regression, right? And it's about managing relatively large data sets. You know, you're dealing with 1,000 elements at once. Right, so when you answer it, you'll hit reply, the reply button that's down here, and then your answers will follow below. When you are replying to your classmates, there will also be a reply button below those that will allow you to respond to an individual posting. If you hit the syllabus tab when you enter Canvas, you'll see 3 items under syllabus. One is actually the course syllabus. You'll be graded on the discussion boards, right? And you'll be graded on the projects. The discussion boards are worth 40%, and the projects are worth 60%. All right, this tells you what topics. It'll tell you on a week by week what the discussion board problem set is. And if you want to know how the discussion boards or the projects are graded, here are the rubrics. Okay? So if you want to know how I'm going to grade you, go to the rubrics. A rubric is just this guide that tells you. You have to have your initial posting done by Sunday night. That's part of the grade. And then how you interact with your colleagues is the other part of the grade in the discussion board. And then the last part is the project. The nice thing about Canvas is that if you look in the syllabus, below the syllabus is a summary of all of the assignments that you have, right? So the first assignment given today is called Contradictions of Statistical Significance, is due by next week, right? And then the week after is the problem is about the relationship between height and GPA. Do you think there's a relationship between height, people's height and grade point average? You're laughing.
I don't think so.
You don't think so. All right. Well, probably many of you don't think so. You know, otherwise, you know, I mean, mine would be really, really low. All right. But the purpose of the exercise is for you to do the regression and see what the statistics give you. There is a difference, folks, between statistical significance, which you'll see in the first project, and practical significance. And that's what I'd like you to understand by doing this exercise. All right, questions about Canvas? Yes?
I want to know what to comment on others' discussion.
What should you comment on others? Well, that's a good question. Let me go back to the discussions, and we'll give you an example. All right, contradictions of statistical significance is the first. Okay, so the question you have to answer yourself, right, is what do you think is causing the contradiction, right, between one thing you'll find out from step 3, right, is that the coefficient, the model is significant. One thing you'll find from step 4 is it's not significant. So that's a contradiction. And I'm asking you to explain. Now, you'll have an answer, right? Benjamin here will have a different answer. You might disagree with him. So when you reply to his post, you're going to say that you disagree, and you'll tell me why. And I'm going to grade you on your submission, but I'm also going to grade you on how you respond. Okay. Do not say great post. Don't. All right. You won't get it. You won't get a good grade for that. And I don't care if it's great or it's not great. What I really want to know is what you think, and especially if you disagree. He might have one reason, you have another. And what would be better is if you can convince him that you're correct, right? Your post is due Sunday, right? You have to comment on 3 other students by Wednesday night, right? That's what your grade will be based on. Does that answer your question? Sure.
Is there any word limits on the posting?
Is there any word limit on the posting? No. No. Well, look, don't make it 1 sentence or 2 sentences, but you can make it long. I mean, the more detail that you provide me that shows me you understand, of course, that's the better grade that you'll get. Okay? Other questions? Yes.
If I don't register for this class, but just audit, will I also get access to the Canvas?
If you audit, do you get access to Canvas? We'll have to talk after class. Okay? Other questions? All right. So let's go back to lecture 2. And we have a few minutes left here, folks. Okay. So this is the data that you saw earlier. What am I trying to determine from this data? The mean, but the mean as the don't worry about beta yet. Beta will come in the discussion board. The mean is the model, right? That's what I'm after, the model that represents and the model that explains this data, right? And we found by the least squares procedure that the model was 1.6, right? And these were all the errors. And when I minimize these errors, I get the model. And this was the best linear unbiased estimator, right? That's what we found. We talked about degrees of freedom and parsimony. And now you want to get on to models with an additional term, and it's beta, or beta 1. So you have now the simple linear regression is 2, right? B0 and B1. Right, B0 is the average, B1 is going to be the slope of the line, right? The mean is the simple model, but we're going to add slopes now. All right, the mean isn't always adequate. You often have more information than that, and I want to get to an example. Here is a part of a map of Los Angeles. And I actually think this may have come from Zillow. And you see all the blue houses are actually houses that are for sale. Okay? Do you think that we can predict the sale price of a house? Can I develop a model that will predict the sale price of this house, of any of the houses? Yes, the answer. How would I do that?
First, you need to develop those house in by the zip code and the size.
Hold on. Zip code?
Yeah.
Okay, what else?
And the size of the house.
Size of the house. What else? Anything else?
And the price they sell like a couple years before.
And past
Yeah, past
sale
sale price.
price. Anybody have any other ideas of things that we could use to predict the sale price of a house? Location. Good. Location's good. Right, so you see this is a section of Los Angeles, right, but I could divide this up so I have a region here, I have another region down here, you know, I have a tight region up here, right, and maybe the house prices in Windsor Hills might be different than what was called Leimert Park up here. Anything else that governs the price of a house?
Number of rooms,
Number of rooms usually is a good one.
status of garage,
A what? Garage?
parking garage.
Garage, yeah. Whether or not you have 0 or 1 or 2 car. So you see there are lots of terms. But let's develop a simple model, right? Can we develop a model just based on the average price alone? Will that predict the price? No, no way. But let's try to determine a simple one, and maybe what I'm going to use is not zip code, because maybe the zip codes are all the same in this region of Los Angeles. You know, but I could say that the, how do I denote a model? Y hat, right? Right, Y hat is equal to the average price that I'll call B0. Somebody said B0, which is good. And then I want to add a term that depends upon the size. So I'll have another coefficient that says B1 times the size. Okay? That's simple linear regression, right? So if I know the size of the house, I can predict it. Will it be a good model? It's hard to say because, look, as we discuss this, there are many factors that affect the size of a house: location, size, number of rooms. Sometimes, you know, whether or not you have a pool, some number of restrooms that you have. There are many factors that, you know, that influence the size of the house. Okay. Right, and here's some of the data that we actually used in order to determine a model. So here are the addresses. Here's the list price. Somebody mentioned previous price before. Was it you? Okay, good. It's not really previous price, but the list price. You know, what's listed for sale. Number of bedrooms, number of bathrooms, and the square footage. Right. So I could have a model that's based on all 4 pieces of this information to determine the price that would actually sell at. Would one data matter? Would one model work, the mean price? No. Right? Because what you get out of it is an average price of $415,690. And you see the sum squared error is actually very large. Right? And then if I asked you what's the price of a house, for any given house in that area of Los Angeles, you would have to tell me $415,690, right? Because that's what the model predicts. So it's not very accurate. Right, so let's finish up today by asking you to fill in one more black box. And how do we add one more parameter? Right, the model is y hat. What's B0? What does B0 represent in this case for a house price? The mean price, the average price. And then what's next? So we want to add a linear function of the number of the size of the house. Right? So this is, I'll call it, can I call it square feet? And is there another coefficient? Right? We'll call it B1. All right, so there you have it. That's a simple linear regression model. Right? We have an average, and based on the size, this is multiplied. Right? You actually have a simple a simple model of regression. Right? There are a couple of more boxes for you to go in and fill in. Right? Go and continue to look at the example. If you have questions, if you're unsure about what is in this, bring the questions back next week. Okay? So you can estimate the model in 4 different ways, and what I'm going to show you next week, or the start of next week, will show you these 4 different procedures for determining the model. And when I say determining the model, I mean determining B0 and determining B1. Right? And there are 4 different ways of doing it. Lastly, if you haven't seen Minitab, it'll look something like this, right? If you use Word or any other typical tool, you'll see a toolbar that is open, save, print, and very typical tools. The window at the top is the output from the software, and I actually solve the problem that I gave you. And so if you have the data set practical.txt and you fill in the regression line, you should get a result that looks like this. All right, so if you don't get a result that looks like this, then you're probably not doing something right with the software. The data, let me move this out of the way, and I can't scroll it. Let's see. All right, remember one of the questions was for you to look at R squared, to explain what R squared means. R squared is in the output. Pen doesn't work on this. R squared for this case is 24.3%, right? That explains the amount of variance. So when you do the regression, you'll go to stat, regression, fit linear model. You'll get a graph that looks like this, okay? And then all of the numerical data will be output in the window that's called session, right? And that's what your results should look like, right? Then the real problem in the discussion board is for you to comment on the output of the session, right? And that's what we're going to ask you to do. All right, we're about done. Any last questions, right? If you have a question, go to the office hour discussion board, please, and post it there. The value of posting it there is that I can answer. Other class members could answer, but then if you have a question, it's likely somebody else has the question too. So you can answer, you'll be able to see what other questions come up. Anything left? Any other questions? Okay, we will not meet on Monday. We will meet here next Thursday, but I'll expect to see the activity on the discussion board during the week. All right, thanks everyone. We'll see you next week.